Most teams think AI just needs access to data, but the real problem? Your context is scattered across DBT, your glossary, observability tools, and tribal knowledge. AI can see your data, but it doesn't know what it means. Here's how we fix that. We've watched hundreds of teams hit the same wall with AI pilots. Snowflake Cortex and Databricks Genie, they work great in demos, but fail in production because the AI doesn't know which revenue definition to use, which tables are deprecated, or whether there are data issues. They're also limited to the data and context that live in those specific platforms, so they don't offer a universal solution. That missing layer, it's context, and that's what we built Atlan to provide. When teams jump straight from data to AI, they fall into what we call the AI value chasm. We see this pattern consistently. AI pilots that work in demos but fail in production. There are 5 different definitions of ARR across finance, sales, and product, and AI picks the wrong one. The talk to data agents generate syntactically correct SQL but semantically wrong queries, and data teams spending 40 hours a week answering which metric should I use because AI can't figure it out. The problem isn't the AI. The problem is AI needs semantic context to understand what data actually means. And that context is trapped across multiple systems, like DBT containing transformation logic and upstream dependencies, BI tools with metric definitions and business logic, data warehouses with column descriptions and sample data, glossaries that have those business definitions, observability tools with quality scores and freshness, and people's heads. Don't use that table, use this one. Think of metadata as the instruction manual for your data. A context layer aggregates that instruction manual from everywhere it lives. It standardizes it and it makes it queryable, so AI systems can actually use it. Here's what this looks like in practice. Now, without the context layer, we would ask an AI agent, what's our Q4 revenue? It would find 5 tables with the word revenue. It would pick the wrong table. It would return the wrong answer, and our finance team would lose trust. Now, with the context layer, the AI agent queries Atlan's metadata lakehouse. It sees a certified revenue finance definition. It finds the lineage showing which tables feed it. It sees quality scores and freshness, and it returns correct answers with confidence. The result? We saw up to 5 times better AI analyst responses in AI labs. We saw that AI moved from experimentation to production, and data teams stopped being the human context layer. So how does Atlan specifically enable this? Well, Atlan acts as the context layer through 3 core capabilities. The first is the context engine. We ingest metrics and lineage from Snowflake, DBT, BI semantic layers, Unity catalog, glossaries, and documentation tools. Then, data and governance team use the Context Studio to curate the right semantic layer for each use case. They describe the use case, like talk to revenue metrics for finance. Atlan automatically finds the most relevant assets, such as tables, data products, and glossary terms, to ground that agent. Teams review and select the right assets, so humans stay in charge of which definitions are authoritative. You end up with a reusable package of context for each use case. So instead of rebuilding logic every time, you apply the same trusted context across agents, dashboards, and workloads. The second is the metadata lakehouse. Under the hood, our metadata lakehouse stores Atlan's metadata in Iceberg tables exposed through an open REST catalog, so engines like Snowflake, Databricks, Spark, Trino, or Presto can query it directly, much like querying system tables in your warehouse. Now, what does this enable? If a customer wants to query Atlan's metadata like system tables from the warehouse engines, that's exactly what Metadata Lakehouse provides. Today, we see teams manually maintaining spreadsheets to get Atlan metadata into their AI or search layers. With Metadata Lakehouse, they can query that same context directly from their warehouse or compute engines instead of pushing CSVs around. Instead of running custom ETL jobs that can take hours, teams query the metadata lakehouse with roughly 15-minute metadata freshness in the raw layer. The third is AI-assisted governance and context refinement. The context layer isn't static. It needs to stay accurate as data changes. Now, we use AI to help in this through our Context Studio, which lets you simulate real prompts and test semantic models against a golden question set, so you can iteratively improve SQL accuracy until you hit your target. Our AI Steward, which automatically suggests descriptions from existing queries and documentation and helps surface likely inconsistencies for stewards to review, and playbooks, which allows for automated enrichment so context quality is high enough for AI to actually use it. Once that context is validated, we publish the semantic model back into Snowflake, Databricks, or other engines as a semantic view definition, or even expose it through SDKs, our MCP, and APIs so AI agents and applications can query that governed context directly. Now, here's the part that most teams miss. The same context layer that makes AI accurate also makes AI governable. In AI Governance Studio, models and agents sit on top of the same metadata graph as your data products. That means you can trace models and agents back to the data products they rely on, see which policies apply to those assets, check quality signals for underlying tables, and understand lineage so you know which upstream changes could break downstream AI behavior. This is how you demonstrate to regulators and internal auditors that AI is governed with concrete controls, not just policy PDFs. Our technical foundation makes Atlan the universal context layer. It has an open format storage in Iceberg via Polaris, multi-platform ingestion with connectors to hundreds of sources. It has per tenant isolation, and it has an MCP, SDKs, and APIs for extending to new tools. This isn't a closed system. It's designed to be the neutral context engine that respects your existing investments, whether you're on Snowflake, Databricks, both, or neither. Now, a common objection we hear is why not just use platform semantic layers? And it's a fair question. Snowflake has semantic views, Databricks has metric views, dbt has metrics, Looker has lookml. Why do you need Atlan? That's because those layers are 1. Siloed per platform. Finance's ARR definition in Looker doesn't match sales ARR in Snowflake. 2. They're optimized for human-authored dashboards, not machine-readable context for AI agents. And third, it's missing cross-system lineage. AI needs to know when upstream changes in dbt break downstream metrics in Tableau. Atlan aggregates and governs semantics across all of these, then publishes platform native views back where they're needed. We're not replacing your semantic layers. We're the layer that makes them consistent and AI usable. Now, what does this unlock? When teams put Atlan in the middle as the context layer, AI agents behave the way you expect. Accurate, explainable, safe to scale. Data teams stop being the human context layer, answering the same metric questions. Time to production drops, turning pilot to production into just weeks, not just stuck in experimentation. And governance and risk leaders can demonstrate AI is governed with concrete controls. This is how enterprises turn their metadata into the context AI needs to get the answers right. If you're evaluating how to make AI work in production at your organization, the missing piece is probably context. Not more data, not better models. You can explore how Atlan's metadata lakehouse, Context Studio, and AI governance capabilities work together by checking out our platform walkthrough linked in the description. And if you want to see how this applies to your specific stack, whether you're Snowflake first, Databricks first, or multi-platform, drop a comment with your setup and I'll point you to the right starting point.